Hi, and welcome to this Now Maths video on factorising quadratic expressions. So first of all, before we get started, what does it actually mean to factorise an algebraic expression? Well, it means that we have to use factors in order to put an algebraic expression into brackets. The different types of quadratic that we'll factorise in this video are on screen right now. There are chapters linked in the description below, so if there are only some of these questions that you would like to see, you can use this to skip to the part that's relevant to you. Alternatively, if you'd like to see more of a revision style video, please find our Revise Now videos linked below. Now, let's get started. So we're going to start by looking at quadratics in the form ax squared plus bx. This quadratic only has two terms and it's one of the only kinds of quadratic that factorises into a single bracket because there is a common factor of x in each of the terms. So we're going to start off by factorising the quadratic expressions on screen fully. To factorise something fully, we need to make sure that we take out the highest common factor in each case. So looking at our first question of 10x squared add 15x, looking at just the numbers first, 10 and 15 have a highest common factor of 5. So we're going to take that to the front of our brackets. We can also see we have an x squared and an x, which have a highest common factor of x, which means that the highest common factor of both terms is 5x. When we've found the highest common factor, we open up our brackets. And then we have to look, what do we multiply 5x by to give 10x squared? Well, we have to multiply by 2x. So that goes first in our brackets. Now we look, what do we multiply 5x by to get 15x? Well, 5x multiplied by 3 would give us 15x. And since the 15x is positive, so is the 3. And we close our brackets off. And this is our final answer. When we've factorised, it's usually a good idea to check our answer, and we can check by expanding the answer back out and making sure that we get what we started with. So starting off with 5x multiplied by 2x, we get 10x squared, and then 5x multiplied by 3 is 15x. This is the exact same as what we started with, so our answer is correct. Now looking at our next question, we have y subtract 3y squared. If we see a letter without a number in front of it, technically that number just has a 1 in front of it. So looking at the numbers first, 1 and 3 have a highest common factor of 1, so we're not going to write that down. Now looking at the letters, y and y squared have a highest common factor of y, so we will write that down. And y is the highest common factor of both terms, so we open our bracket up. We now need to know what we multiply y by to get y, that's just 1, and what we multiply y by to get negative 3y squared, that would be negative 3y. Now for our quick check, we expand back out to ensure that we get what we started with. So y multiplied by 1 is just y. And then y multiplied by negative 3y is negative 3y squared. And this answer is the same as what we started with, so our answer in red is correct. Now looking at our final question, we have 16a squared subtract 40a. Looking at just the numbers first, 16 and 40 have lots of common factors, so they have a common factor of 1, 2, 4 and 8. Since 8 is the highest common factor, we're going to take 8 to the front of our brackets. We can also see that we've got an a squared and an a, which have a highest common factor of a. So we take 8a to the front of our bracket as our highest common factor. Now looking at what we multiply 8a by to give 16a squared, we have to multiply it by 2a. Then looking what we multiply 8a by to give negative 40a, we have to multiply by negative 5. And then we close our brackets off. Now just to perform our quick check, we can expand back out to make sure that we get what we started with. So 8a multiplied by 2a is 16a squared. And 8a multiplied by negative 5 is negative 40a. And again, This matches what we started with, so our answer in red is definitely correct. Now you've seen a few examples of how to factorise these two-term quadratic expressions, you might want to pause the video here and have a go at a few for yourself. When you're ready to see some solutions, press play. If you pause the video, welcome back. For our first question, the highest common factor of 5x squared and 20x is 5x, so we take that to the front of our bracket. Then 5x squared divided by 5x is x, and 20x divided by 5x is 4. And the 4 is positive because so is the 20x, and we close our brackets, and that's our final answer. For the second question, we have 14b squared subtract 7b. The highest common factor is 7b, and we open our brackets. Then 14b squared divided by 7b is 2b, and negative 7b divided by 7b is negative 1, and we close our brackets. For question number 3, we have no numbers, which means there is technically a 1 in the front of each of these terms. This means that 1g is the highest common factor of each, or just g, and we open our brackets up. Then g squared divided by g is g, and negative g divided by g is negative 1. And we close our brackets off, and that's our final answer. And for the final quadratic, the highest common factor of 27y squared and 36y is 9y. Then 27y squared divided by 9y is 3y, and 36y divided by 9y is 4. And we close our brackets off. Really well done if you managed to have a go at these questions independently. The next type of quadratic we're going to take a look at is on the screen now. This sort of quadratic you might be more familiar with seeing, and it factorises into double brackets. Now let's take a look at how. So looking at our first quadratic that we're going to factorise fully, we have x squared, add 7x, add 10. The reason this quadratic doesn't fit into a single bracket this time is that none of the 3 terms we have any common factors at all other than 1, and we'll typically never write a 1 on the outside of a bracket when factorising. So we're going to fit this quadratic into double brackets this time. And in the front of our double brackets, to give us x squared, if we were to multiply these brackets out, we would need to have an x in the front of each, because x multiplied by x gives us x squared. In the end of each bracket, we need to find 2 numbers which multiply to give us positive 10 and add to give us positive 7. So I'm just going to write down a few numbers which multiply to make 10. So we could have 1 and 10, we could have 2 and 5, and that's all of the factor pairs of 10. Now out of the 2 pairs we have, 2 and 5 is the only pair which add to give us positive 7. So we're going to put in the end of our brackets 2 and 5, and because 2 and 5 are both positive numbers, we need to put a plus in front of each. And this is our final answer. Similar to previously, we can check our answer by expanding out these double brackets and making sure we get what we started with. So expanding out, x multiplied by x is x squared. Then x multiplied by 5 is 5x. Then 2 multiplied by x is 2x. And 2 multiplied by 5 is 10. Then simplifying this, we can see we have like terms of 5x and 2x, which add together to make 7x. So altogether we have x squared, add 7x, add 10, and this answer is the same as what we started with, so the answer that we had in red is definitely correct. Now looking at our second quadratic, we're again going to factorise into double brackets since there are no common factors in any of the 3 terms other than 1. We know that we need an x in the front of each of our brackets, given that x multiplied by x gives us our x squared. And then this time we need to look for 2 numbers that multiply to give us positive 40 and add to give us positive 13. So let's write down some numbers which multiply to give positive 40. So we could have 1 and 40, we could have 2 and 20, 3 isn't a factor, but we could have 4 and 10, and we could have 5 and 8. And that's all of the factor pairs that multiply to make 40. Out of all of our pairs, the only pair that add to make 13 is 5 and 8. So in the ends of our brackets, we write 5 in one and 8 in the other, and since 5 and 8 are both positive numbers, we put a plus in the front of each, and this is our final factorisation. We won't do it this time, but similar to last time, if we wanted to check that this answer is definitely correct, we could expand and simplify the brackets and make sure that we get what we started with. Another thing to note here is that if you were to write these brackets in the opposite order, so x plus 8 first, followed by x plus 5 second, this would also be a correct answer. That's because these brackets are being multiplied together and multiplication is commutative, which means it doesn't matter which way we do it. Now you've seen a couple of examples of factorising quadratics like this, you might want to pause the video here and have a go at a couple of questions for yourself. When you're ready to see the answers, press play. If you press pause, welcome back. So for our first question, we know that we're factorising this into double brackets since there are no common factors in all of the terms, and we know we need an x in the front of each since x multiplied by x gives us x squared. For this particular question, we need to look for two numbers that multiply to give us 16 and add to give us 10. Just so we can see what numbers might do that, the factors of 16 that we could have are 1 and 16, 2 and 8, or 4 and 4. The only one of these pairs that adds to give positive 10 is 2 and 8, since 2 add 8 is 10. So in the end of each bracket, we have a 2 in one and a 10 in the other. 2 and 10 are both positive numbers, so we need a plus in the front of each. And this is our correct factorised quadratic. Similar to the previous example, if you had your brackets in the opposite order, so x plus 10 first, followed by x plus 2 second, this would also be a fully correct factorisation. For our second question, we know we're going into double brackets again because there are no common factors other than 1 in the three terms, and we know we need an x in the front of each bracket since x multiplied by x will give us our x squared. We now need to find two numbers which multiply to give us 25 and add to give us 10. Listing the factors of 25, we only have two different options this time, either 1 and 25 or 5 and 5. The pair which add to give us positive 10 is 5 and 5. So in the end of each bracket, we write a 5 in each. And since 5 is positive, we need plus in front of each of those 5s. And this is our correct factorised quadratic. Given that the brackets are identical this time, there would be no difference if we were to swap these brackets around. However, if you wanted to, you could also write this as x plus 5 all squared, because that shows that that bracket is being multiplied by itself. Great work if you had a go at those questions independently. Now we've taken a look at some questions like this that have all positive terms, we're going to have a look at some similar questions that have a mix of positive and negative terms. The method for this is exactly the same, except we're going to have to be a little bit more careful about dealing with the negative numbers. So we'll start by looking at how to factorise the question on the left. Similar to the previous questions, we know that this quadratic is going to factorise into double brackets since there aren't any factors greater than 1 in the question. We also know that to give us x squared, we're going to need an x in the front of each bracket, since x multiplied by x gives us x squared. Now, similar to the previous questions, we're going to be looking for numbers this time that multiply to give us negative 45 and add to give us negative 4. So we're going to start by looking for numbers that multiply to give negative 45. If we want two numbers to multiply to make a negative number, we need one of the numbers to be negative and the other to be positive. So for example, we could have negative 1 multiplied by 45. Or we could swap the negatives over and we could have negative 45 and 1. 2 isn't a factor of 45, but 3 is, so we could have negative 3 and 15 that multiply to make negative 45, or negative 15 and 3. 4 isn't a factor of 45, but 5 is, so we could have negative 5 and 9, or negative 9 and 5. 6 isn't a factor of 45, 7 isn't, 8 isn't, and we already have 9, so this is all of the pairs. Now we've listed all of the pairs, we need to find out which pair add to give negative 4. Well, negative 1 add 45 is going to make 44. Negative 45 add 1 makes negative 44. Negative 3 add 15 gives 12, and negative 15 add 3 gives negative 12. Negative 5 add 9 gives positive 4, and negative 9 add 5 gives negative 4. So the final pair is going to be the pair which add to give negative 4. And this time in our double brackets, we're going to have negative 9 in one and positive 5 in the other. So our fully factorised quadratic is x subtract 9 in one bracket and x add 5 in the other. And similar to the previous questions, these brackets can be written in either order. So the x plus 5 could go first, followed by the x subtract 9 second. And both of these answers are correct. Now looking at the question on the right, this time we have x squared add x subtract 20. Just before we start factorising this, we could actually write this as x squared add 1x subtract 20 to help us to begin with. Now we again know that this is going to factorise into double brackets since none of the three terms have any common factors greater than 1, and we know that we're going to have an x in the front of each bracket since x multiplied by x is x squared. This time we're going to have to look for two numbers that multiply to give negative 20 and add to give positive 1. So let's start by listing some numbers that multiply to make negative 20. Similar to the previous question, to multiply to give a negative number, we need one number to be negative and the other to be positive. So starting our list off, we could have negative 1 multiplied by 20 to give negative 20. Or the other way around, we could have negative 20 and 1. We could have negative 2 multiplied by 10, or negative 10 multiplied by 2. 3 isn't a factor of 20, but 4 is, so we could have negative 4 and 5, or negative 5 and 4, and that's all of the factor pairs of negative 20. Now we need the pair which add to give positive 1 this time. Out of all of the different pairs, the pair that adds together to give 1 is negative 4 add 5. So in the ends of our brackets, we have negative 4 in one and positive 5 in the other. And this is our fully factorised quadratic. And similar to previous questions, we could write this the other way round. So x add 5 first and x subtract 4 second. And either answer would be correct. Now you've seen a couple of questions like this, you might want to pause the video and check if you can factorise the quadratics on screen now. When you're ready to check some solutions, press play. If you pressed pause, welcome back. Now let's have a look at some solutions. So for our first quadratic, similar to all of the previous ones, we're going to put in double brackets and we're going to have an x in the front of each bracket since x multiplied by x is x squared. For this question, we need two numbers which multiply to give negative 33 and add to give positive 8. To multiply to give a negative number, we need one negative number and one positive number. So the possible factors are negative 1 and 33, negative 33 and 1, or negative 3 and 11, or negative 11 and 3. Out of all of the pairs that we've listed, we need to find the pair which add to give positive 8. To add to give a positive number, the positive number in the pair will have to be greater than the negative, and negative 3 add 11 is positive 8. So for our factorised quadratic, we need negative 3 in one of the brackets and positive 11 in the other. And similar to all of the previous questions, if you were to write the brackets in the opposite order, this would also be a correct factorisation. Now taking a look at the question on the right hand side, again we know we're going into double brackets here and we know we need an x in the front of each bracket. And for this particular question we need to find two numbers which multiply to make negative 16 and add to make negative 6. So listing our numbers which multiply to make negative 16, we could have negative 1 and 16, negative 16 and 1, negative 2 and 8, or negative 8 and 2, and finally negative 4 and 4. We then need to find the pair which add together to give negative 6, and the only pair which add to give negative 6 are negative 8 and 2, since negative 8 add 2 gives negative 6. And so for our factorised quadratic, we put a negative 8 in one bracket and a positive 2 in the other, and this is our fully correct factorised quadratic. Alternatively, if you had the brackets the other way around, this would also be a fully correct factorised quadratic. Really well done if you had a go at these questions independently. Now we're going to take a look at some other questions with both positive and negative terms, except they're in slightly different places this time. So if we look at the first question on the left-hand side, we're going to start off by putting down double brackets, and we know that there's going to be an x in the front of each, since x multiplied by x gives us x squared. And this time we're looking for two numbers that multiply to give positive 6 and add to give negative 5. If we're looking for numbers that multiply to give positive 6, we could either have two positive numbers or two negative numbers, since a negative number multiplied by another negative number gives a positive answer. In this particular case, if we're looking for the numbers to add to give negative 5, then the two numbers are going to have to both be negative, since two positive numbers could never add to give negative 5. So if we list some numbers that multiply to make positive 6, we could have negative 1 and negative 6, or negative 2 and negative 3. And they are all of the negative factors of positive 6. Now out of these pairs, negative 1 add negative 6 is negative 7, and negative 2 add negative 3 is negative 5. We needed the numbers to add to give negative 5, so we're going to choose negative 2 and negative 3. So in our double brackets, we're going to have negative 2 in one of them and negative 3 in the other. And this is our fully factorised quadratic. And just as with the previous questions, we could have the brackets in the opposite order. So x subtract 3 first, followed by x subtract 2 second. Now looking at the question on the right hand side, again we know this is going to factorise into double brackets, and we know there's going to be an x in the front of each bracket, since x multiplied by x gives us x squared. This time we're looking for two numbers that multiply to give positive 50 and that add to give negative 27. And similar to previously, if we're looking for two numbers that multiply to give us a positive number but add to give us a negative number, both numbers will have to be negative. So listing the pairs of negative numbers that multiply to make positive 50, we would have negative 1 multiplied by negative 50, negative 2 multiplied by negative 25. 3 isn't a factor of 50, neither is 4, but 5 is. So negative 5 and negative 10 multiply to make positive 50. 6 isn't a factor of 50, 7 isn't a factor of 50, 8 and 9 aren't, and 10 we already have, so that's all of the factors. Now we need the pair that add to give negative 27. So negative 1 add negative 50 is negative 51. Negative 2 add negative 25 is in fact negative 27. And just to double check, negative 5 add negative 10 is negative 15. So the middle pair is going to be the pair that have the correct sum. So that tells us to write negative 2 in one of our brackets and negative 25 in the other. And this is our fully factorised quadratic, and same as previously, the brackets can go in either order, so either answer on screen is acceptable. Now you've seen a few questions like this, you might want to pause the video here and have a go at factorising the quadratics on screen. When you're ready to see some solutions, press play. If you pause the video, welcome back. Let's take a look at some solutions. So for our first quadratic, we know we're going to put it into double brackets, and we will have an x in the front of each bracket, and we're looking for two numbers that multiply to give positive 15 and add to give negative 8. If two numbers are going to multiply to give a positive number and add to give a negative, both of the numbers are going to have to be negative. So we could have negative 1 multiplied by negative 15, or negative 3 multiplied by negative 5. Out of the two, the pair that add to give negative 8 is going to be negative 3 and negative 5. So in the ends of our brackets, we will have negative 3 in one and negative 5 in the other. And as always, the brackets can go in either order, so either answer on screen is correct. Looking at the question on the right hand side, again we're going into double brackets and we will have an x in the front of each bracket, and we're looking for two numbers that multiply to give positive 21 and add to give negative 22. Again, the two numbers have to multiply to give a positive number and add to give a negative, so both numbers will have to be negative. So we could have -1 and -21, or -3 and -7. The pair that add to give -22 is going to be -1 and -21. So in the end of each of our brackets, we will have -1 and -21. This is our fully factorised quadratic, and again, the brackets can go in either order, so either answer is acceptable. Really well done if you paused and had a go at those questions. Now we're going to look at quadratics in the form ax squared subtract c, where a and c are usually square numbers. When these numbers are squared, this is called the difference of two squares, since it is a subtraction and both terms are square numbers. Now let's have a look at some examples of how to factorise the difference of two squares. So looking at the first question, this is definitely a difference of two squares because it's a subtraction, which is a difference, and x is being squared, and 16 is the square of 4, because 4 times 4 is 16. Now looking at the entire quadratic, there aren't any factors greater than 1 that go into each term, so we can't put this into a single bracket, which means we are going to put the expression into double brackets. And then to factorise, we're going to use square roots to help us. So the square root of x squared is x, so we're going to put x in the front of each bracket. Now the square root of 16 is 4, so we're going to put 4 in the end of each bracket. And given that these two 4's need to multiply to give us -16, one must be positive and the other must be negative. Now just to check that this has worked, we're going to expand the double brackets out and check we get what we started with. So starting off with x multiplied by x, which is x squared. Then x multiplied by -4, which is -4x. Then +4 multiplied by x is +4x. And +4 multiplied by -4 is -16. Then we can simplify this expression because we have -4x and +4x, which add to give 0, which leaves us with just x squared subtract 16. And this is exactly what we started with, so our factorisation in red is correct. Now looking at the second question. This again is a difference of two squares because it's a difference or a subtraction, and each of the terms are square numbers. There is no factor greater than 1 that goes into each term, which means we can't factorise into a single bracket, so we have to factorise into double brackets. We're then going to use square roots to help us. So the square root of 4b squared is 2b, because 2b multiplied by 2b is 4b squared. Then the square root of 25 is 5. So we put a 5 in the end of each bracket. And since we need these 5's to multiply to give -25, we need one of them to be positive and the other to be negative. And similar to the previous question, if we wanted to perform a quick check that this answer is definitely correct, we could expand the double brackets out and check we get what we started with. So 2b multiplied by 2b is 4b squared. Then 2b multiplied by -5 is -10b. Then 5 multiplied by 2b is +10b. And finally 5 multiplied by -5 is -25. And similar to last time, we can collect the like terms, so -10b add 10b is 0, leaving us just with 4b squared subtract 25, which is exactly what we started with, so our factorisation in red is correct. Now looking at our third and final quadratic, we can see that this is a difference of two squares again because it is a subtraction or a difference, and each of the terms are square numbers. There are no factors greater than 1 in each of the terms, so we can't put this expression into a single bracket, so we need to put it into double brackets. And again, we use square roots to help us here. So the square root of 9x squared is 3x. Since 3x multiplied by 3x is 9x squared, so that goes in the front of each of our brackets. And then the square root of 4y squared is 2y, since 2y multiplied by 2y gives us 4y squared. And since we need the two y's to multiply to give us negative 4y, one of them needs to be positive and the other needs to be negative. And this is our full factorised quadratic. We won't go through the full expansion of how to check this quadratic this time, however I will put up the expansion on screen if you're interested in checking. Now you've seen a few examples of factorising the difference of two squares, you might want to pause the video here and have a go at factorising the expressions on screen now. Come back when you're ready to see some answers. If you paused, welcome back. Now let's have a look at some solutions. So all of these quadratics are differences of two squares and all of them factorise into double brackets since none of them have factors greater than 1 that go into each term. So for the first quadratic, we're going into double brackets. The square root of y squared is y, so that goes in the front of each bracket. And the square root of 9 is 3, so that goes in the end of each bracket. And given that these 3's need to multiply to give negative 9, one needs to be positive and the other needs to be negative. This is our fully factorised quadratic. Now looking at the second question, again we're going into double brackets. And first of all, the square root of 25a squared is 5a, since 5a multiplied by 5a is 25a squared. Then the square root of 4 is 2. And given that we need the 2's to multiply to give negative 4, we need one of them to be positive and the other to be negative. Just a little side note here, if you decided to write the brackets in the opposite order to what I have, then you will still have a fully correct factorisation. Now looking at the third quadratic, we're again going into double brackets. And first of all, the square root of a squared is a, so we put an a in the front of each bracket. Then the square root of 16b squared is 4b, since 4b multiplied by 4b is 16b squared. And given that we need the 4b's to multiply to give negative 16b squared, we need one to be positive and the other to be negative. And this is our fully factorised quadratic. And for the final question, again we're going double brackets, and the square root of 25x squared is 5x, since 5x multiplied by 5x is 25x squared. And then the square root of 36y squared is 6y, since 6y multiplied by 6y is 36y squared. And given that we need these 6y's to multiply to give negative 36y squared, we need one to be positive and the other to be negative. And again, this is our fully factorised quadratic. Really well done if you paused and had a go at these questions. Now for the last type of quadratic we're going to factorise in this video, we're going to look at quadratics that have a coefficient of x squared that is greater than 1. That means we will be able to see a number in front of the x squared. This type of quadratic is usually the most difficult to factorise, since we can't just put double brackets with an x in the front of each, because the first term is not just x squared in these quadratics. To try and make these questions easier, in this video we're going to use a method commonly known as either the AC method or factorising by chunking. So we'll start off by looking at a couple of examples with only positive numbers, and then we'll work our way towards examples that have negative and positive numbers. To use this method, the first thing we're going to do is label the coefficient of x squared a, or the number before the x squared a, the coefficient of x b, or the number before the x b, and the constant on the end c. What we'll then do is we're going to work out the value of AC. And our value of A in this question is 2 and C is 20. And we multiply them together, which gives us 40. Now we need to look for two numbers which multiply to make 40 and add to make 13. So we're going to find the factors of 40 first. Since 40 is a positive number and 13 is a positive number, we're only going to need to look at the positive factors. So we could have 1 and 40, 2 and 20, 4 and 10, or 5 and 8. Now we need the pair that add together to make 13, and in this case 5 add 8 makes 13, so this is the pair we're going to use. We're now going to go back to the question and we're going to rewrite the quadratic that we started with, except instead of writing 13x, we're going to write 5x add 8x. And then we're going to put our plus 20 back on the end. This quadratic here is identical to the quadratic above. The only difference is that we have split up the 13x into two separate terms. The reason that this is helpful is that we're now going to factorise this quadratic in two halves. And we're going to factorise each half into a single bracket. So first of all, looking at just the first half of this quadratic, the highest common factor of 2x squared and 5x is just x. So we're going to take a factor of x to the front of our single bracket. Now, 2x squared divided by x is 2x, and 5x divided by x is 5. So that's the first half of our quadratic factorised. We're now going to factorise the second half. So looking at 8x and 20, these terms have a highest common factor of 4. So we're going to take a factor of 4 out. And then 8x divided by 4 is 2x. And 20 divided by 4 is 5. If we factorise fully both halves, what should happen is we should end up with a common factor in each half. In this case, the common factor is 2x plus 5. So we now have an expression with two terms in it, each of which has a common factor of 2x plus 5. So we're going to factorise again and we're going to take out a factor of 2x plus 5. Now looking at the first term, if we divide this first term by 2x plus 5, we should be left with x. So we open up a second bracket and x goes in first. Now looking at the second term, if we divide by 2x plus 5, we're left with 4. So we put plus 4. And given that there are no more terms, we can close the bracket off, and this is now our fully factorised quadratic. Similar to all of the previous questions, if we wanted to check this, we could expand the double brackets back out and check that we get what we started with. Now looking at a second example of using this method. The first thing we need to do is label the x squared coefficient a, the x coefficient b, and the constant c. We then work out the value of AC. In this case, A is 6 and C is 10. And to work out AC, we multiply them together. So 6 multiplied by 10 is 60. We now need to find two numbers which multiply to make 60 and add to make 19. Given that both of the numbers are positive, all of the factors need to be positive. So we could have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, or 6 and 10. Now we need the pair which add together to make 19. So looking at our list, 4 and 15 will add together to make 19. So we now go back to the original quadratic and we rewrite it as 6x squared. And instead of writing 19x, we write plus 4x plus 15x. And we put our plus 10 back on the end. Again, this quadratic here is identical to the quadratic above. The only difference is we've split up the 19x into two separate terms. And the reason that this is helpful is that we can now try and factorise our quadratic in two separate parts. So looking at the first part first, 6x squared and 4x have a highest common factor of 2x. So we bring that to the front of our bracket. And then 6x squared divided by 2x is 3x. And 4x divided by 2x is 2. And we can close our bracket off. Then for the second half, 15x and 10 have a highest common factor of 5. And then 15x divided by 5 is 3x. And 10 divided by 5 is 2. and we can close our bracket. We now have an expression with just 2 terms in it, and we have a common factor of 3x plus 2 in both. So we're going to factorise again, and we're going to pull out a factor of 3x plus 2. Now looking at the first term, if we divide the first term by 3x plus 2, we get 2x. So opening up a new bracket, we're going to have 2x first. Then looking at the second term, if we divide the second term by 3x plus 2, we get 5. So we have plus 5. And given that there are no more terms left, we can close our bracket, and this is now our fully factorised quadratic. Now you've seen a couple of questions using this method, you might want to pause the video here and have a go at the questions on screen. When you're ready to see some answers, press play. If you paused, welcome back. Now let's have a look at some solutions. So for the first question, the first thing we need to do is label A, B and C, and then we need to work out the value of AC, which in this case A is 3, C is 8, and we multiply together, which gives us 24. And we need two numbers which multiply to give 24 and add together to give 10. So listing the numbers which multiply to make 24, we could have 1 and 24, 2 and 12, 3 and 8, or 4 and 6. Now the pair which add together to make 10 is going to be 4 and 6. We now go back to our original quadratic, and we rewrite the middle term. Instead of 10x, we write 4x add 6x. So we'll have 3x squared, add 4x, add 6x, add the extra 8 on the end. The point of doing this is then to enable us to factorise in 2 separate halves. So looking at the first half, the highest common factor of 3x squared and 4x is x. Then 3x squared divided by x is 3x, and 4x divided by x is 4. Now looking at the second half, the highest common factor of 6x and 8 is 2, and 6x divided by 2 is 3x, and 8 divided by 2 is 4. We now have a quadratic with 2 terms in it, and both terms have a common factor of 3x plus 4. So we factorise again by taking out a factor of 3x plus 4, and dividing the first term by 3x plus 4 gives us x. Then dividing the second term by 3x plus 4, we get 2. And this is our fully factorised quadratic. As with all of the previous factorisations, if you had the brackets in the opposite order, this would also be a correct factorisation. And this would have happened if you wrote the 4x and the 6x in the opposite order. Now looking at the question on the right, we have A, B and C. Working out the value of AC is going to be 6 multiplied by 12 this time, which is 72. And we need numbers which multiply to make 72 and add to make 17. So looking at the numbers which multiply to make 72, we could have 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, or 8 and 9. Out of all of the pairs, the pair that adds together to make 17 is going to be 8 and 9. So we now go back to our original quadratic and we rewrite as 6x squared. We then split the 17x into 8x, add 9x, and we put the plus 12 on the end. Now we factorise in 2 separate parts. So looking at the first half, 6x squared and 8x have a highest common factor of 2x. So we pull out a factor of 2x, and then 6x squared divided by 2x is 3x, and 8x divided by 2x is 4. Now looking at the second half, 9x and 12 have a highest common factor of 3, so we pull out 3, and 9x divided by 3 is 3x, and 12 divided by 3 is 4. We now have an expression with just 2 terms in it, and we have a common factor of 3x plus 4 in each term. So now we factorise again and we take out a factor of 3x plus 4. Then if we look at the first term, if we divide by 3x plus 4, we're left with 2x. And then looking at the second term, if we divide by 3x plus 4, we're left with 3. And this is our fully factorised answer. Again, the brackets could be written in the opposite order and still be correct. Now we're going to have a look at a few questions that use the exact same method except have a combination of positive and negative terms. The only thing we need to be careful about is the negative numbers here. So if we're using the same method, we're going to label A, B and C first. And this time A is 5, B is 13, but C is negative 6. So when we work out our value of AC, A is 5, C is negative 6, and 5 multiplied by negative 6 is negative 30. Now we need to find two numbers which multiply to make negative 30 and add to make positive 13. To multiply to make a negative number, we need one of the numbers to be positive and the other to be negative. So for example, we could have negative 1 multiplied by 30, or we could have negative 30 multiplied by 1. We could have negative 2 multiplied by 15, or the other way around, negative 15 multiplied by 2. We could have negative 3 and 10, or negative 10 and 3, negative 5 and 6, and finally negative 6 and 5. Now we need to find the pair which add together to make 13, and out of all of the pairs, the only pair which add to make positive 13 is going to be negative 2 add 15. So now we need to go back to the original quadratic, and instead of writing a positive 13x, we write a negative 2x and a positive 15x. So we'll write down 5x squared, subtract 2x, add 15x, and subtract 6. So this expression is the exact same as the one above, except this 13x has been split up into two terms. We're now going to do exactly what we did before and try and factorise this in two separate parts. So looking at the first half, 5x squared and negative 2x have a highest common factor of x. So we take x to the front of our brackets, and then 5x squared divided by x is 5x, and negative 2x divided by x is negative 2. Now looking at the second half, 15x and negative 6 have a highest common factor of 3. So we take a factor of 3 out, and then 15x divided by 3 is 5x, and negative 6 divided by 3 is negative 2. And we can see we've now got two separate terms, each with a common factor of 5x subtract 2. So we now factorise again, and we take out a factor of 5x subtract 2. And then dividing the first term by 5x subtract 2 is x. And dividing the second term by 5x subtract 2, we get 3. And since this is all of the terms, we can close our bracket back off, and this is our fully factorised quadratic. Now let's take a look at another similar question with a negative number in it as well. So first of all, we need to label our x squared coefficient A, x coefficient B, and constant C. We then work out the value of AC, which in this case, A is positive 4, C is positive 6, and 4 multiplied by 6 is 24. We now need to find two numbers which multiply to make 24 and add to make negative 11. In order for two numbers to multiply to give a positive number and add to give a negative, we must be looking for two negative numbers. So let's list the negative numbers which multiply to make positive 24. So we could have negative 1 multiplied by negative 24, or negative 2 and negative 12. Negative 3 and negative 8, or negative 4 and negative 6. Now we need to find the pair which add together to give negative 11. Out of the four pairs that we have, the only pair which add to make negative 11 are negative 3 add negative 8. So we're now going to go back to the original quadratic, And instead of writing negative 11x, we're going to write negative 3x and negative 8x. So we will have 4x squared, subtract 3x, subtract 8x, add 6. And same as all of the previous questions, this quadratic is identical to the one above. It's just the middle term that has been split up. So we now need to factorise, but in 2 halves. So looking at the first 2 terms, 4x squared and negative 3x have a highest common factor of x. So we take x to the front of our bracket, and 4x squared divided by x is 4x, and negative 3x divided by x is negative 3. Now looking at the second half, we have a negative 8x and a positive 6. The highest common factor of these 2 terms is 2, and given that the first term is negative, I'm going to take out a factor of negative 2. Now, negative 8x divided by negative 2 is positive 4x, and 6 divided by negative 2 is negative 3. Now we have an expression with only 2 terms in it, and each term has a common factor of 4x subtract 3. So we're going to pull this out as a common factor. And if we divide the first term by 4x subtract 3, we get x. And if we divide the second term by 4x subtract 3, we get negative 2. And since that's all of the terms, we can close our bracket, and this is our fully factorised quadratic. And as previously, the 2 brackets could be written in either order. Now we're going to have a look at one final example of factorising a quadratic with 2 negative terms. So labelling across A, B and C, we work out AC, which in this case A is 4 and C is negative 15. Then 4 multiplied by negative 15 is negative 60. We now need 2 numbers which multiply to give us negative 60 and add to give us negative 4. In order to multiply to make a negative number, we need one of the numbers to be negative and the other to be positive. So for example, we could have negative 1 and 60, or we could have negative 60 and 1. We could have negative 2 and 30, or negative 30 and 2. We could have negative 3 and 20, or negative 20 and 3. We could have negative 4 and 15, or negative 15 and 4. We could have negative 5 and 12, or negative 12 and 5. And finally, negative 6 and 10, or negative 10 and 6. So we've got lots of factor pairs here. And we need the pair which add together to give negative 4. If we add all of these together and check, the only pair which add to give negative 4 is the very last pair of negative 10 add 6. So we're going to go back to the original quadratic, and instead of writing this middle term as negative 4x, we're going to write negative 10x and positive 6x. So we will write 4x squared, subtract 10x, add 6x, subtract 15, and again this quadratic here is exactly the same as the one above. We've just split this middle term into 2. We're now going to factorise in 2 separate halves, and looking at the first half, 4x squared and negative 10x have a highest common factor of 2x. So we'll have 2x in front of our bracket, and then 4x squared divided by 2x is 2x. And negative 10x divided by 2x is negative 5. Then similarly, looking at the second half, the highest common factor of 6x and negative 15 is 3. And given that the first term is positive, we'll pull out a positive 3. And then 6x divided by 3 is 2x. And negative 15 divided by 3 is negative 5. Now we can see we have 2 terms, each with a common factor of 2x subtract 5. So we factorise again and we pull out a factor of 2x subtract 5. And dividing the first term by 2x subtract 5, we get 2x. and dividing the second term by 2x subtract 5, we get 3. And this is all of the terms, so we close our brackets, and this is our final factorised quadratic. Now for the final time in this video, you might want to pause here and have a go at the 2 questions on screen. Come back when you're ready to see some solutions. If you paused, welcome back. Now let's have a look at some answers. So for the first question on the left, the first thing we need to do is label x squared coefficient A, x coefficient B, and constant C. We then work out the value of AC, which in this case A is 6 and C is negative 5, and 6 multiplied by negative 5 is negative 30. We now need to find 2 numbers which multiply to give negative 30 and add to give negative 13. In order to multiply to give a negative number, we need one of the numbers to be negative and one of the numbers to be positive. So for example, we could have negative 1 and 30, or negative 30 and 1. We could have negative 2 and 15, or negative 15 and 2. We could have negative 3 and 10, or negative 10 and 3. We could have negative 5 and 6, or negative 6 and 5, and that's all of the factor pairs. Now we need the pair which add to give negative 13, and out of all of the pairs on screen, the only pair which add to give negative 13 are negative 15 and 2. So we now go back to the original quadratic, and instead of writing negative 13x, we write a negative 15x and a positive 2x. So we have 6x squared, subtract 15x, add 2x, subtract 5. And this quadratic is identical to the one above, and we now factorise in 2 halves. Now factorising the first half of this quadratic, the highest common factor of 6x squared and negative 15x is 3x. So we pull out a factor of 3x, and 6x squared divided by 3x is 2x. Then negative 15x divided by 3x is negative 5. Now looking at the second half of the quadratic, 2x and negative 5 actually don't share any common factors that are greater than 1, which means in this particular case we're actually going to have to take out a factor of 1 because that is the highest factor. Then if we open up our brackets, 2x divided by 1 is 2x, and negative 5 divided by 1 is negative 5. And we can see we now have a quadratic with 2 terms in it, and each one has a common factor of 2x subtract 5. So we take out a factor of 2x subtract 5. And if we divide the first term by 2x subtract 5, we're left with 3x. And if we divide the second term by 2x subtract 5, we're left with 1. And this is now our fully factorised quadratic, and those brackets could be written in either order. Now looking at the second question on the right hand side, again we start off by labelling A, B and C. We work out the value of AC, which in this case A is 8, C is negative 4, and 8 multiplied by negative 4 is negative 32. And then we're looking for 2 numbers which multiply to give negative 32 and add to give positive 31. For 2 numbers to multiply to give a negative answer, we need one of the numbers to be negative and one of the numbers to be positive. So we could have negative 1 and 32, or negative 32 and 1. We could have negative 2 and 16, or negative 16 and 2, and negative 4 and 8, or negative 8 and 4. And that's all of the factors in this case. The only pair which add to give positive 31 is going to be the very first pair. So we're going to rewrite our quadratic, but instead of writing a positive 31x, we're going to write a negative 1x and a positive 32x. So going back to the original quadratic, we rewrite as 8x squared, subtract 1x or subtract x, add 32x, and subtract 4. We now need to factorise this quadratic in 2 halves. So the highest common factor of 8x squared and negative x is x, so we take out a factor of x. And 8x squared divided by x is 8x. And negative x divided by x is negative 1. Now looking at the second half of our quadratic, the highest common factor of 32x and negative 4 is 4. So we take out a factor of 4, and 32x divided by 4 is 8x. And negative 4 divided by 4 is negative 1. Now we can see we have a quadratic in just two terms, and there is a common factor of 8x subtract 1 in each. So we take out a factor of 8x subtract 1. And if we divide the first term by 8x subtract 1, we get x. And if we divide the second term by 8x subtract 1, we get 4. And this is all of the terms, so we close up our bracket, and this is our fully factorised quadratic. And again, the brackets could be written in either order. Thank you so much for watching this Now Maths video on factorising quadratics. Please give the video a like if you found it helpful, and subscribe if you would like to see more content like this. See you next time.